Threads are the fundamental building blocks of concurrent applications, but working directly with threads has a couple of problems. The first problem is that we have a limited number of threads available to us. So if you're not careful, we may end up creating too many threads and get out of memory exceptions, so our application will crash. The other issue is that creating and destroying threads is costly. If you have 1,000 tasks to execute, like 1,000 images to download, and only 10 threads available, we have to download 10 images using these threads. Then once these threads are complete, we have to create another set of 10 threads, and we have to repeat this several times to execute all our tasks. Creating and destroying threads is expensive. So Java 5 came up with a solution called a thread pool. A thread pool is essentially a pool of threads called worker threads, and this thread can be reused to execute several tasks. When a worker thread finishes, it's returned back to the pool, so it can be reused to execute another task. So these threads are not destroyed and recreated. They're always available and are reused to execute many tasks. Also, because a thread pool has a fixed number of threads, we don't have to worry about creating too many threads and running out of memory. For example, we can create a thread pool with 10 threads and submit 1,000 tasks to it. The thread pool would take care of assigning our tasks to these threads. If all threads are busy, the new tasks will wait in a queue. As soon as a thread becomes available, it will pick up a task from the queue and execute it. So with this model, we don't have to think about creating threads directly. Instead, we submit our tasks to a thread pool and let the thread pool take care of thread manipulation. I'll show you how to do that next.